Hello everyone,
Welcome to our tutorial on COMSORT, a simple yet effective sorting algorithm. Today we'll walk through how this algorithm works using a specific example, the array 8, 4, 1, 3, 5, 2. Let's get started.
Step 1. We start by calculating the initial gap. The gap is found by dividing the array length by 1.3. For our array of 6 elements, 6 divided by 1.3 is approximately 4.6, which we round down to 4. Step 2. Now we compare elements that are gap distance apart. So we compare the first element, 8, with the element 4 positions away, which is 5. 8 is greater than 5, so we swap them. Next, we move 1 position to the right and compare 4 with 2. Again, 4 is greater than 2, so we swap these as well. With no more elements 4 positions away to compare, we calculate a new gap. Dividing 4 by 1.3 gives us approximately 3. Using this gap of 3, we start from the beginning again, comparing 5 with 3. 5 is greater than 3, so we swap them. Continuing with gap 3, we compare 2 with 8. And since 2 is less than 8, no swap is needed. Next, we compare 1 with 4. Since 1 is less than 4, we leave them as they are. We reduce the gap again, this time to 2, and continue our sorting process. With this new gap, we start from the beginning of our array once more. Our first comparison is between 3 and 1. 3 is greater than 1, so we'll swap these two. Next, we compare 2 with 5. Since 2 is less than 5, no swap is needed here. Moving on, we compare the next pair according to our gap of 2, which is 3 and 8. Again, 3 is less than 8, so we leave them as they are. Finally, we compare 5 with 4, which are the last pair that can be compared with this gap. 5 is greater than 4. So we need to swap these elements. The array becomes 1, 2, 3, 4, 8, 5. With the array looking more sorted, we reduce the gap once more, this time to 1. At this stage, COMSORT essentially operates like a bubble sort, ensuring any remaining unsorted elements are properly positioned. We'll now do a final pass through the array, comparing adjacent elements. Starting with 1 and 2, they are already in order, so no swap needed. Next, we compare 2 and 3, and they are also in the correct order. Then we compare 3 and 4. Again, no swap needed as they are in the right order. Following this, we compare 4 and 8, and these are correctly placed as well. Finally, the last comparison is between 8 and 5. They are also incorrectly ordered, so we swap them. And there you have it, our array 8, 4, 1, 3, 5. 2 is now fully sorted to 1, 2, 3, 4, 5, 8. This demonstrates how COMSORT efficiently reduces the time spent on sorting by tackling larger gaps early on and then fine-tuning with smaller gaps. If you enjoyed this video and learned something new, please give us a thumbs up. We love making these tutorials for you, and your support really helps us keep going. Don't forget to subscribe to our channel for more tutorials like this one. Hit the bell icon so you won't miss any of our future videos.